Good morning, everyone, or good afternoon, as the case may be. My name is Rene Morkos. I did my PhD at Stanford University, and I have been at the bleeding edge of AI in construction for 14 years at this point. I have raised $62 million from Silicon Valley investors, and I've watched a lot of my friends and colleagues do the same. Our department at Stanford, SciFi.stanford.edu, started doing research in AI for construction. The papers that I built my PhD on top of were really, they started thinking about converting BIM models into schedules and optimizing construction using AI, I think in 1994. So they've been at it for, close to 3 decades at this point. What I'm going to show you today is maybe a little bit of a different take on AI. I'm not going to focus on construction at the outset. What I'm going to do is I'm going to tell you guys about AI broadly, and then I'll give you an example of some of the work that we've done, and we'll go from there. Before I get started, let me just kill this screen over here, which is bouncing around. Hopefully that will fix the problem. Okay. All right, let's see if it fixes it. So, how many of you are familiar with Moore's Law? For those of you that are not, Moore's Law states the number of transistors on a microchip shall double every 18 months. He wrote that law in 1965. Everything in Silicon Valley, you could say that the Silicon Valley mantra is Moore's Law. Our staffing models, our obsolescence models, our innovation, models, our business plans, everything was based on the fact that computers double in strength every 18 months. Now, if you look at how many years have passed since 1965, when Gordon Moore was the CEO of a company called Intel, 58 years have passed since he wrote this law. Now, you can do some really interesting math with this knowledge. How many 18 months periods passed since 1965? And the answer is 39.3 18-month period passed. 2 to the power of 39.3 gives you 676 billion. So what this is telling you is that today's computers are 676 billion times stronger than they were in 1965. Kind of a nice back-of-the-envelope math equation. Now, if you plot Moore's Law on a logarithmic scale, so notice that this is sort of doubling every 18 months, gives you a straight line, you'll see that the integrated circuit has given us this ability, this magical ability of doubling our compute power every 18 months since 1965. What most people don't know, even those familiar with Moore's Law, is that Moore's Law has actually been around since before 1965. It's been around with transistors since about 1960. Well, actually, Moore's Law has been around since 1945 with vacuum tubes. Well, actually, Moore's Law has been around with relays since about 1935. What most people don't realize is actually Moore's Law has been around since 1900 with mechanical computers. I want you to just think about this for a second. Moore's Law has been around for 125 years, and it represents 10 million trillion increase in our species' ability to compute over the last 125 years. Kind of crazy when you think about it. So, what does that mean for us? Where are we and where are we going? A gentleman called Ray Kurzweil, who used to be chief futurist at Google, turns out that's a job, in 2001 wrote this document, and it was called The Law of Accelerating Returns. Well worth a Google. Kurzweil, Law of Accelerating Returns. It's a 40-page document. It's just fascinating. In 2001, he wrote this document, and he said the human brain is about 100 billion neurons. an average of 1,000 connections per neuron. These neurons, each connection can do about 200 calculations per second. So long story short, a human brain is equivalent to 2 times 10 to the power of 16 calculations per second. Okay. He wrote this in 2001. So why is that relevant? Well, in 2001, what he predicted was we would achieve one human brain capacity around the year 2023. Really interesting to note that in 2023, we saw the advent of ChatGPT. I think it was 3. He also predicted something else. What he predicted was that we're going to achieve one human race capability, which is 2 times 10 to 26 calculations per second in the year 2049. So once again, what he said that you'd be able to, for $1,000, that was a number, you'd be able to buy a human brain capability for in 2023, and you would buy the entire human species. So this number multiplied by about 10 billion in 2049 for $1,000. So that's the thing that's kind of crazy. So let's take a look at some of these models. I'm going to make an assumption that most people in the audience have heard of ChatGPT or LLMs and OpenAI and what's happening in that field. If not, definitely worth a Google. Large language models such as OpenAI, ChatGPT, etc., run on neural networks. I have a version of this presentation if it's going to explain how neural networks work. It is also well worth, if you go to YouTube and just Google how do neural nets work, there's a bunch of 7-minute, 8-minute videos out there, and it's well worth it because the way they work explains why they do what they do and why they hallucinate, for example, and why they're good at sort of solving, complex problems. But back to my point. They're neural networks. Instead of pixels, they are fed words, and they answer one question. And that question is, what is the next word? So what they've done is they've basically fed these neural networks, I think it's 1.7 terabytes of data, kind of roughly everything on the internet. And what's interesting about them is when you type a question in, what it does is predicts the next word, and based on that, it predicts the next word and the next word and the next word. It turns out that it can actually write things that are very, very understandable. So here's an example. The sky is usually blue, right? That's a good guess for what that next word is. That's what this technology is doing, except it ingests, 1.7 terabytes of data, incredible amount of data to run what it runs. Yeah. So let's take a look at these large language models. In 2018, GPT-1 had about 117 million parameters. In 2019, it had 1.5 billion. In 2020, it had 175 billion. And in 2023, it has 1.7 trillion. That's 1.7 times 10 to the power of 12. Now notice Kurzweil's prediction, which he said we achieve one human brain capability, which is 2 times 10 to the power of 16 around the year 2023. Now, I'm not claiming that parameters, 1.7 trillion parameters, are equivalent to calculations per second. I'm not claiming that. But what I am saying is that there's a pretty strong correlation between the two. Kurzweil in his document actually states that even if you change those numbers, because of the fact that the darn thing is doubling every 18 months, because 18 months from now, it's going to be double this. It's going to be 2 times 10 to the power of 17, and then 18, right? 18 months from there. So you're seeing that it starts to basically, this 1.7 trillion times 10 to the power of 12, when in 18 months it's 10 to the 13, 18 months is 10 to the 14. So within 2-3 years, you'll have 10 to the 16 parameters inside of this GPT program. Just another piece of information, what it takes to train these models is about $40 million today, $30 to $40 million. Microsoft and Google both are talking about investing about $100 billion into training these things. So you're going to see a substantial increase in the capacity and capability of it. And that's kind of, I think, one of the reasons that what we're seeing is so surprising, right? These machines are starting to have a similar capability in some ways to what our human brains can do. Um, there are differences, right? They're not as fast at being able to train these models. They can, as you notice, like ChatGPT only can read the internet up to a certain date. But on the other hand, it can read the entire internet before that date. So there's a correlation between these two figures. But again, my point is that what we're seeing is humans are being able to do more and more machine-like or human-like tasks. And I think this, what I'm showing you here, is why. So let's sort of summarize neural networks a little bit. They have two really big advantages. You don't have to explain to the neural net how to solve your problem. That's what's fascinating about it. You don't have to explain to ChatGPT or any of these technologies how to write a poem or how to um, uh, write a specification, how to read, drawings or documents. They sort of learn or do it by themselves. They work really well on unstructured, fragmented data sets. You don't have to explain to them how to read a whole bunch of information. They have two really big disadvantages. They're never 100% accurate. As you guys know, they hallucinate. And they can't tell you how they solve the problem. It's a really, really interesting piece of the puzzle. You can't ask a neural net if it wrote the poem or why it wrote the poem that it did or why it answered what it answered. You ask questions the numbers in those 1.7 trillion parameters. Those parameters have a number between 0 and 1, and basically that neural net assigns a number between 0 and 1 to those 1.7 trillion parameters. That is the answer of how I wrote the poem, which to us humans is just not very understandable. What does this mean for construction or AEC, more broadly? We have large data sets. One of them, the reasons that we're the second least digitized industry in the world is not because we're lazy and stupid, but just simply because our problems are bigger and more complicated than problems in other fields. BIM, for example, was invented in AEC with ArchiCAD in 1983, I believe, but really took off in mechanical engineering because the 3D models for engines are just smaller than for buildings. So it's interesting that we've had BIM technology since the 80s. It wasn't really until I think 2015 the machines were caught up where they could crunch, the models required for architectural models. The other issue is the large sort of data sets. We have large, unstructured, fragmented data. We have complex data interrelationships between these fragmented data silos. We have hard to define non-standard problems. Even, for example, what I'm going to show you today, what we built with Alice, there is no definition of, there's no conceptual model or process model for how we standardize information in construction. It represents 10% of world GDP, and this entire amount is managed with that. This is the state-of-the-art construction management. And so at Alice Technologies, we've built a system, let's hope this video runs, where we are able to either ingest a BIM or a Primavera P6 file or Microsoft projects coming out soon, maybe in the next couple of weeks. And so the way it works is you ingest a 3D model of something you want to build, and you set up the constraints. So for example, in this case, to install that pipe, we're going to install some hangers, lift and secure, weld, pressure test. And each of these tasks has some resources. You sort of visually set the constraints up inside the BIM. As of 8 weeks ago, we released a complete different product, which is you can just simply upload a schedule. So basically what you see here is we drag the schedule into the software. What we're doing to that schedule is converting it into a constraint model. A lot trickier than it sounds. And now you can open the schedule that you're familiar with inside of the software, which by itself really is great as a viewer, I guess, but this is where the magic happens. And so what you're able to do for the first time ever is what you're seeing on the left side of the screen over here is all the different simulations you can run. And what you're going to do now is you're going to run a simulation of overtime, and you're simply going to change the calendar. And once you've changed the calendar, you just run scenario. Each of these dots is a fully resource loaded simulation. And so you see here that overtime shortened my duration from somewhere around 420 days down to somewhere around 380 days. So we just saved about 30 days by implementing overtime. You can run lots of, the sky's limitless. You can change anything you want. You can shuffle crews between tasks, reducing or increasing float. You can try multiple crews. You can put crew ranges, which is really like fascinating. You can optimize without resequencing. You can automatically resequence your work around delays. You can change production rates globally. You can use budgeted labor units and production systems or production rates, and so on and so forth. It's really anything you can think of. You can just change it. The system simply like updates the constraint model, propagates it, runs it for you, spits out the results. And then what you can do is you can click on each of these dots. As much as I like to joke, they're great as abstract art. But when you open those dots, you get an automatically generated schedule. And then here on the right side, you're seeing an automatically generated 4D. So that's what I've spent the last 14 years building. So that end-to-end import to BIM, upload constraints, simply import your schedule, run lots of simulations, add cranes, add crews, change overtime, whatever it is, shuffle resources, increase, decrease float, and it then spits out the optimal solution. Usually you can generate about 600 million fully resource loaded simulations in the course of an afternoon. The software will pick the fastest, cheapest, etc. We tend to see about 17% reduction in duration, about 30% reduction in labor and equipment costs. We're deployed on HS2, for example, and a number of other projects around the world. It's great for infrastructure, data centers, and we've done large-scale commercial jobs and so on and so forth. The latest release with this schedule import means that now we can do projects that are as small as $10 million and up. So what does that mean for construction? VC investment in construction tech have doubled from 27 billion in this 3-year period to 50 billion from 2020 to 22. The large software players know that there's this almost fight for the future of construction right now, and are actively fighting this out. Large-scale acquisitions, Autodesk acquired sort of PlanGrid, Building Connected, Procore is making acquisitions, Oracle bought out Aconex for $1 billion, and so on and so forth. Really, really exciting time to be in our field. Construction, in my opinion, is going through the biggest transformation in the last 2,000 years, and it's happening now. This is the most exciting time to be in construction. What's happened in construction today is what happened to manufacturing in the 1970s. It's getting digitized, optimized, and connected. And it's just incredibly beautiful and exciting to see what's going on. I think that there should be 10x as many startups as there are. There should be 10 times as many Alice technologies in the world. And what's really great is watching these new startups coming online, integrating with the larger players and integrating with each other. And what's really beautiful about what's happening is everybody can play this game. If you're that's what I realized. If you're an executive at a company, if you're an individual contributor at a company, if you're a journalist, a reporter, whatever it is, if you're a student, you can get in on this incredible transformation that's happening. That's, I think, incredibly exciting. And that's really my presentation. The machines have caught up and just keep doubling. That's my contact if you want to reach me, and thanks for your time.